All right, so I'm in the horizontal curve review. Share my screen. David, if you will log in just so you can see if you can share my screen. The rest of them aren't. And I want to make sure you can see my screen before I accidentally do something.
Yes, I can see it.
All right, so we are going to do a vertical curve. This is a really long vertical curve. Yours will not be near this long for the test. So it's a 1,000-foot vertical curve. It's used to join a grade, a plus 4% grade. So I'm going to call that my G1. And a negative 3% grade, so that's going to be my G2. The vertex is at 62 plus 0, 0. And the elevation is 462.75. So I kind of drew it up. This is the V. There's your elevation, 462.75. It's a 1,000-foot vertical curve, grade 1, grade 2. Now, what's happening is when we're trying to solve for the elevation on the vertical curve. So what we're solving for in that chart are these elevations actually on the curve. So typically when we do vertical curves, or we do them in CAD, we'll do straight segments and tell it to smooth it out, because you can't drive up that hill and then straight back down without bottoming out your car. So that's why we put the smooth vertical curves in there. And we got to solve for these elevations. Chart's the easiest way to do it. CAD does it for us and labels it for us, so that's really great. But if you're starting to get to higher level, if you decide you want to pursue surveying or engineering, you would see this type of problems on the exam. All right, so I'm going to flip over. So I'm actually in chapter 25 now. I've got the pages that I'm going to be looking at. This is going to be kind of like similar to example 25-1. I'm going to go ahead and solve for R first. So R is G2. So that was a negative 3 minus G1, which is a 4, divided by L in stations. So L in stations would be 10, because it was 1,000 feet. So your R should be a negative 3 minus a 4 divided by 10. So I got 0.7 for my R. Negative. All right. Next thing. I want to get my station numbers. So it's the station number at V. So that was our V right here. And we're going to say minus L over 2. Well, L was 1,000 feet. So divided by 2 would be 500 or 5. So the beginning vertical curve is 57 plus 0, 0. And then to get the end vertical curve, it's plus L, and it'll give you 67 plus 0, 0. So on your vertical curve test, this one just happens to work out that the begin vertical curve and end vertical curve were even station, which is great. So the problem I'm working is even station, but a lot of times they don't work out to be an even station. So kind of pay attention to that. If you're not knowing sure how to do this, you want to do 62 minus 1,000. Well, 1,000 would be 500 because I do 1,000 divided by 2. And you get 5,700. Just know the plus goes 2 decimal places over. So that would be 57 plus 0, 0. So now I need to get the beginning vertical curve elevation, and I'm going to go ahead and do the end vertical curve elevation. So beginning elevation, the beginning vertical curve is going to be the elevation at V. Always use, to get, this is the begin vertical curve, always use a negative there and keep your signs. So it'd be the 462.75 minus my G1, which is 4, times L over 2 in stations, which would be 5, equals 442.75. I did see someone, I'm trying to think what to do. Because we're using the grade, that grade is 4%. Because we're using 4%, that's why our L has to be in stations and not in feet. So to make the actual computations work out easier, they'll tell you to do it in stations. They tell you that on page, let's see, 761, like when they're doing their R, it says divided by the length in stations. So make sure L is in stations. So that's my beginning vertical curve elevation. If you get that wrong, then it's going to be a domino effect on everything else. And we're just doing a straight line grade. Now to do the elevation at the end vertical curve, I would say always do a plus and keep your signs. It will always work out right. So it'd be your elevation at B plus G2 times L over 2. So there's where the beginning vertical curve elevation plus, and it's a negative 3% grade times 15, and you get 447.75. For the begin, put V minus whatever your G1 times L over 2, and just keep your signs. You will never be wrong. And then for the elevation at end vertical curve, if you always do the elevation at V plus G2 times L over 2, you will always be correct. And then the last equation we use is for the elevation of any point on the curve. It's going to be begin vertical curve plus G1 times X plus RX squared. So that's where the chart comes into play. So I've already got the chart worked up. Ooh. I've already set my chart up. Use this. So on the test the other day, the beginning vertical curve was, let's say, 56 plus 40. I saw somebody do 50 7 plus 40 and just went to one and did one station. It's not. You go to the nearest next one up. So if this would have been an odd station like 5750, your first one would be 58, would only be 0.5. This actually X is in stations from the beginning vertical curve. So these were 100 feet that worked out. So the first one, it's 1, and then between 59 and 57 is 2. So I'm just going up 1 every time. You'll go up 1 every time, but usually your first and last ones are odd. And your last one should always be L over 2. So I think y'all had like, I'm not sure. Let me pull that. Let me look at the test that you had. It was supposed to be 55 plus 40. So your first even station would be 56. So that's only 60 feet. So your X should have been 0.6. And then you should have went up 1.6 to the next one, 2.6. And then when you get to the end, you should have had your 10 stations. This is a perfectly even one, so it worked out great. G1 times X is my next column. My G1 for the problem is 4. So this one's going to be an easy one. So 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 24. Oh, 12, duh. I was thinking 8. 12, 16, 20, 24, 28, 32, 36, and 40. Okay. I'm going to put these in a different color. This is a real simple one, but it's still getting the point across. So this is G1 times X. So G1 is 1, G1 is 4 times 1, so this is 4. So 4 times 2, looks like that. Rx squared divided by 2. So my R's 0.7. I notice a lot of times I'll see ones that already take the R and go ahead and divide it by 2. So that'd be a negative 0.35. So then here's what they do. So you've already got the R divided by 2, which is 0.35. Now you're going to say times your X. So I'm going to 58. So I'm in this column right here. That gives me a negative 0.35. So I like how it does that, but so I'm going to go ahead and put that number right here at the top is a negative 0.35. And then I just have to do my X squared. So the next one would be 2 squared times a negative 0.35. So that gives me a negative 1.4. And then I'm going to go to 12, and that's going to be a negative 315. And then 61, which is 16, if I do 16 squared times a negative 3.5. Oh, I did the wrong thing. It's 4. I was just looking at 4 squared times a negative 0.35. That's a negative 5.6. A negative 8.75. A negative 12.6. A negative 17.15. Another truck somewhere. It's all right, I'll just do it by hand. So my 8 squared times a negative 0.35, negative 22.4. And then I got 9 squared times negative 0.35. That's a negative 28.35. And the last one is 10 squared times a negative 0.35. Should be 35. Now remember the formula. Beginning vertical curve plus g1 times x plus rx squared will give us the curve elevation. So we're going to come all the way back to this one. So for the first line, I'm going to say 442.75 and plus 4 and plus my negative plus 4 plus my negative 0.35. That's what I get. And that would be correct. So for 59, it's going to be 442.75 plus 8 and plus a negative 1.4. And I get 449.35. And then I'm going to 60. I get 451.60. And for 61, I get 453.15. For 62, I get 454.00. 63, I get 454.15. And then station 64, I get 453.60. And then I'm going to have to calculate the other 3 because when the page cut off. So I've got to do 65. So I'm going to do 442.75 plus 32 minus 22.4. I get 452.35. 442.75 plus 36 and then minus 28.35. 450.40. And the last one is 442.75 plus 40 minus 35. 447.75. Now I can do a check. I'm going to look back over and see what we got for the end vertical curve. That's a check. Now, pretty much so I'm done with this, but if I wanted to make sure that I don't have an error, I can do the first difference, second difference right here. And I probably would. These are all 100 foot, so it's going to be easy. But if yours is not 100 foot, you can only do the first difference, second difference for the ones that are 100 feet. So, so most likely you would just do the very next two that are down below. So you would start at the top. So I'm going to do 447.75 minus a 450.40. So that gets me a negative 2.65. Okay, and then I'm going to do the next two. I would spend the time on a test to do this. You will not have a 1,000-foot problem. I'll go ahead and tell you that. I had not worked this one out ahead of time, but I'm going to do it now. Hopefully I'm putting them in the right place. And they show you in the book how to do this. So 453.15 minus 451.6. Try this for the third time. And then now I'm going to do my second differences. So I'm going to do them in a different color. So negative 2.65 minus a negative 1.95 gives me a negative 0.7. So that's my R. So you should be getting R. So I'm going to do a negative 1.95 minus a negative 1.25. 0.7 negative. think that's a negative number there. So 0.85 minus. I skipped that one. All right, all checks out. Yay, we're done. Last thing. What's the high point station for this problem? I'm going to use equation 25-7 on page 762. Our G1 was just a 4, right? And our R is a negative 0.7. That gives me 5.714, and I'm going to round up to 3 because it's 4.8. You want to keep that to 4 decimal places, because in feet, that would be 571.43. So if I want to get the station, it'll be the station at your beginning vertical curve plus x. So the beginning vertical curve is 57 plus, and that would be 5 plus 71.43. So I can do 5,700 plus 571.43. That station number for the high point should be 62 plus 71.43. A lot of times I put it back in my chart. I come back in that chart and look around that 571.4. I plug it in there. Okay, now I need to get the elevation. So beginning vertical curve elevation is 442.75 plus G1 times X. So G1 is 4, so 4 times 5.7143. So I'm going to say 4 times my 5.7143 plus my R, which is a negative 7, divided by 2 times 5.7143 squared. Let me move my station out of the way real quick. Delta station. All right, so 4 times 5.714. That gives me, let me do a different color. And we know then half of 0.7 is that -3.5 times, and then I'm going to say 5.7143. We're going to square that. I'm just going to keep it like that. All right, so 442.75 plus my 22.8572 minus 11.4286. I got 454.18. So that's my elevation. Because this was a crest, I had a high point. If it would have been sag, it would have been a low point. So there's where we're at. I am going to save this. Solutions. I'll save that as a PDF. That's going to cooperate. So you could see everything, right?
Yes, ma'am.
Okay. All right, so that would be, I was recording, that would be all that you would have for vertical curves. I don't think there's anything else. So I'm gonna stop recording and then I'm gonna leave